Hello everyone, and welcome back to another remote sensing lecture video. And in this lecture video, I want to move away from radiometric errors and talk about geometric errors. And so I want to recap what we left off last time talking about clouds. And we said that clouds have two sort of impacts. They can directly obscure imagery or potentially alter pixel values if it's a haze, or they can produce shadows that have their own separate impact on imagery. So they directly and indirectly right, indirectly meaning shadow, obscure parts of imagery. Okay. So in this video, I want to move our attention towards this idea of geometric error, which we talked about as being times when the pixels were in the wrong location. And I mentioned that there are two sorts of geometric error. There's location error, which is basically where the entire image is in the wrong place. And then there's terrain displacement, which is where objects appear distorted in the image. And I want to actually talk about terrain displacement first. So let's go ahead and spend this lecture video talking about the idea of terrain displacement. And terrain displacement really has a lot to do with the internal geometry of the relationship between sensors and the objects that they're sensing. And I don't want to get too bogged down into the specifics on this because it's a lot of terminology and a lot of geometry and things that we're not really concerned about with this course. But what I want to sort of draw your attention to is this idea of nadir imagery and how we actually have imagery being collected. Oh, it's supposed to be a different color. Right? And so you can imagine if this bit back here, if this is the, right, if this is the sensor, right, and then somewhere in front of the sensor, some small distance away, right, we have, you can think of this as the lens. Right, it's a little more complicated than that, but you can think of this as the lens, right, that focuses light. And then this is the ground down here. Right. What I want to do is I want to draw two buildings. I'm going to do one in red, and it's going to be directly underneath, right, or as close as I can draw it, right, directly underneath the lens. And then I want to draw another building in gray, maybe say a little bit farther away, so it's not directly underneath the lens, right? And so they're going to be identical, right? They're both the same height, the same shape. But I want you to watch what happens as I start to draw lines that run from the sensor through the lens onto the image, right? So if we were to connect the top of this going through the lens, right, it's going to end up here. Right. If we were to draw a line from the bottom of the sensor, or from the bottom of the object, right, through the lens, right, it's also going to end up here. Right, so if you were to look at this image, right, this object would just be a square because the top and the bottom are directly on top of each other. Now let's do the same thing for this gray object here. Right, if I draw a line from the top of the object, all right, as best as I can to keep it straight, right, through the lens, right, it's going to end up here. Right. Now, if I were to draw a line from the bottom of the object, passing through the lens as straight as I can keep it, right, it's going to end up here. Now, if you were paying attention carefully, you're going to notice two things. One is that the image flipped what was on the ground. That's okay, right? We can deal with that. The bigger issue is that because this thing right here, this object here, was not directly under the lens, we call this nadir, right? Because this object was not directly underneath the lens, right? It was at an angle relative to the lens, it ended up being distorted, right? The top was here and the bottom was here. So rather than it being a square on top, now it's going to be this sort of elongated sort of rectangle. And you'll be able to see the sides of the object, even though it's a vertical straight object, just like the red one was. So right, this right here, this relationship between things directly in the middle of the image showing up as vertical and things sort of towards the edge of the image showing up as elongated and being able to see both the top and the bottom in the image. Right? This is terrain displacement. Right? So terrain displacement, sort of to put a definition to it, right, is errors caused when objects are not centralized in the image. This can also be caused by changes in height, slope, or slope. Right? Hopefully you understand how this could be applied if we were to change the height of the object, right? Because if this was flat on the ground, it wouldn't have the same problem, or if we were to put it on like a slope. So this is the diagram of terrain displacement. What I want to do really quickly is I want to actually look at a real example. Okay. Right, so we have an image on the left and an image on the right. This one has been corrected for terrain displacement, and this one has not. And what you can hopefully see here is that in this image, right, we have the circle of the object straight down. We don't see much of the sides. This is what we would expect if we were to look down with our eye down on the thing. Here, though, however, you can see that we can see all of this understructure, right? Even though it is supposed to be a straight vertical tower, right? In this image with terrain displacement, right, you can see that what we have now is we have this object over here. We can see the top, the side, and the bottom as if the object were being slanted. And that's just because of the fact that it is no longer central in the image, or in this case, because of its height. I know terrain displacement can be a little bit confusing. Hopefully this made sense. We can correct for terrain displacement using algorithms and elevation information. That's kind of outside of the scope of this course. Hopefully this makes sense. And as always, if you have any questions, please reach out. Thank you.